Section 8.6, Transformations and Similarity. What you'll learn to describe a sequence of transformations that maps one figure onto a figure that is similar, and to determine whether two figures are similar by using a sequence of transformations. Why learn this? Well, consider that smartphones and tablets have a zoom feature that makes a figure larger or smaller. A swipe feature lets you slide the figure around on the screen. When you use these two figures together, the final figure is similar to the original figure. Before moving farther, let's have a quick check of the skills you'll need. Number 1, vocabulary review. If two polygons are blank, then the corresponding angles are congruent and the lengths of the corresponding sides are proportional. Number 2, in the figure below, triangle VWX is similar to triangle YZX. Find the value of P. Example problem 1, determining similarity using transformations. Now keep in mind we've done something similar in the past where we've actually determined congruence using transformations. In the past we just didn't have access, I suppose, to the transformation called dilation. And when not dilating, our transformations maintained both the size and shape of the figure. And so it remained a congruent figure. Now that we're incorporating dilations, our figures will be similar but not necessarily congruent. So let's check the example out. You use the zoom and swipe features on your smartphone to enlarge and then move an image of a bee on the screen. Describe the sequence of transformations that maps the original image of the bee onto an image that is similar. So we can see the original image, a bee looking kind of small and bee-like. The zoomed in image, probably using the two-finger spread to zoom in on the image. And then the final image, it looks like we swiped in order to pull the bee more centered in the picture. Very good. So to describe that, let's check out the book's description. In a moment, you'll be asked to explain a series of transformations that is very similar to this one. So here's how the book takes care of this example problem. A dilation with a scale factor of 3.5 maps the original image of the bee onto the first zoomed-in image. Now, nowhere here are we told specifically how large the bee is in any of the sequences of transformations here. So I don't see how we have the information to state scale factor of 3.5. It makes sense. The bee looks about 3.5 times larger, but without knowing that information, we couldn't really state that on our own. A translation to the left maps the zoomed-in image onto the final image similar to the original image. So that makes sense. So first, basically a zoom, so we call that a scale factor, or a dilation with a scale factor. That, by the way, results in an enlargement. And then a slide, which we call a translation, to the left in order to basically recenter the bee. All right, so let's check out the quick check. Number 1, using a computer, a graphic designer moves a company logo from the top left of a page to the bottom center of the page and then enlarges the logo as shown at the left. Notice we do know the dimensions of this logo. It goes from being a 1 inch by 1 inch square to being 3 inch by 3 inch square. Notice right away that's an enlargement, and you can also determine the scale factor. Continuing on with the quick check problem, describe the sequence of transformations that maps the original logo onto the final logo. And holy cow, it's your check your understanding already. What if I missed something? I better go check the textbook. Well, it's official. I just checked the textbook. And yeah, there was a little bit more information in the section about two different ways to describe some transformations. But I deliberately skipped that. I think we're here. Here is your check your understanding assignment. Problems 1 through 6. Work carefully.